An egg drop from space is a creative and challenging experiment that involves dropping an egg from a high-altitude position in Earth's atmosphere, often from a near space or suborbital altitude, and ensuring that the egg survives the descent without breaking. This experiment combines elements of physics, engineering, and aerospace technology. Here's an overview of how such an experiment might be conducted. High-altitude balloon launch. To perform an egg drop from space, a high-altitude balloon is typically used to carry the experiment to the edge of space. The balloon is equipped with instruments to record altitude, temperature, pressure, and other data during the ascent and descent. Payload container. Inside the payload container attached to the balloon, an egg or eggs are securely placed. The container is designed to protect the egg from the harsh conditions of space, including low pressure and extremely low temperatures. Parachute system. To slow down the descent and reduce the impact force upon landing, a parachute system is often included in the payload. The parachute is deployed at a specific altitude during descent. Tracking and recovery. The payload container is equipped with GPS and tracking devices to monitor its position during the flight. A recovery team is typically on standby to retrieve the payload once it lands back on Earth. Testing variables. Scientists and experimenters may test various variables, such as the type of padding or materials used to protect the egg, to determine the most effective way to prevent it from breaking upon impact. Data collection. Throughout the experiment, data is collected on the conditions experienced by the egg, including temperature, pressure, and any accelerations it undergoes. Analysis. After the successful recovery of the payload, the condition of the egg is examined to determine if it survived the drop intact. Data collected during the experiment is analyzed to gain insights into the challenges of re-entry and landing. Egg drop experiments from near space are engaging educational activities that teach students and enthusiasts about the principles of physics, engineering, and the conditions of near space environments. While the eggs themselves may not technically reach space, space begins at the Kármán line, which is approximately 100 kilometers or 62 miles above sea level. These experiments provide valuable hands-on learning experiences and can spark interest in STEM, science, technology, engineering, and mathematics fields.